All right, now we're going to work the third part of example 5.5. And in this particular example, the object is at constant velocity. So once again, I'm going to start by drawing a diagram to figure out what all my forces are on this object. Now it says a man is pushing a 2.2 kilogram object across a floor at a constant velocity of 2.1 meters per second. If the man exerts a force of 15 newtons to keep the box going, what is the coefficient of kinetic friction between the box and the floor? Okay, so I have my box sitting on the floor, and I know that the man is pushing it, and in the picture, it's showing me that he's pushing it this direction. So here's the force that he's applying, and I know that it is 15 newtons. I've been told that. I also know that friction is always in opposition to the direction of the motion. So I also know that the frictional force is going to go this direction. The box is sitting on a floor, so therefore it's going to have the weight acting down. And because I'm assuming the floor is level, therefore I'm going to have the normal force acting upward. So what about this other information that they've given me here? They told me that the velocity is 2.1 meters per second squared, and they told me that the velocity is constant. If the velocity is constant, what does that mean about the acceleration? Well, acceleration, if velocity is constant, acceleration has to be zero, right? So what does that mean? Well, if there is no acceleration, that means that these forces have to be balanced with one another, okay? So if these forces have to be balanced, that means that the applied force has to be equal to the frictional force that's happening. Therefore, if you are going to use the equation that the author gave us before, which was kind of a compilation of the fact that any acceleration is due to the applied force minus the frictional force. In this particular case, because the acceleration is zero, this whole side over here becomes zero. And so therefore, if I move this frictional force to the other side, the applied force has to be equal to the frictional force. They have to be the same. Can I figure out either one of these? Well, I know that the frictional force is 15 newtons. I've been told that. Well, what's the frictional force? Well, the frictional force is going to be, because it's already moving, it's going to be the coefficient of kinetic friction times the normal force. Well, here I am again with the normal force. I'm going to have to figure out what that normal force is. The normal force is going to be the same as the weight, which is the mass times the gravity. So if the mass is 2.2 kilograms, and the acceleration due to gravity is 9.8 meters per second squared, that means that my normal force then is going to be equal to 22 newtons. So therefore, I can come down here, and normal force is right here, so I'm just going to put that in here, 22 newtons. And then I can now solve for the coefficient of kinetic friction by taking 15 divided by 22, and I'm going to have a 0.68 for my coefficient for kinetic friction. Again, it's newtons divided by newtons, and so the units all cancel, which makes sense because whenever I have a coefficient of friction, it doesn't have any units on it. Okay, so now we have done an example of an object at constant velocity, which means there's no acceleration, which is this one. Part one was where the object wasn't moving, and part two of the problem that we already did was where the object was moving with an acceleration. So we've basically done some sort of friction problem with the object in any kind of a state of motion. So hopefully that will give you enough examples that you will then be able to go through and work some of the problems on your own. Now this is where the vast majority of the problems are in the chapter. You should always start by drawing a diagram and figuring out what everything looks like, and then being able to go from there. And one of the other things, as soon as you have got this diagram drawn, you need to ask yourself, what kind of motion am I talking about? Am I trying to start the motion? Is it at constant velocity, which means there's no acceleration, or do I have acceleration? And once you've got the diagram drawn and once you've got the problem analyzed as to what kind of motion you have, it will be much easier then to get those problems worked. If you need help, please make sure you ask me.